I guess this one we already done it in the previous one. Like allocate memory, we know that how to do that. And like just here, I think the only the name has been changed for the new class.
Yeah.
Some member function we can copy from that, right?
Yes, yes.
So like this one, I think till I think get element replace swap read print. Okay, like I think till here, right?
Yep.
This have been already done. I think we can copy paste from till these functions from there. We have to make from start from this one, right? Make identity.
Okay.
Okay. So yeah, like should I discuss every function or like I should ask like have you done this or not or like I give a brief idea of every function, right? That be fine?
Yes, yes. Like, I think whatever I just don't have, I can ask you. So yeah.
Sure, sure. So yeah, like firstly we'll start with the make identity function. Like what it says is make the current matrix an identity. Means change we know that how what is the identity matrix. Let's try to discuss it. Like I think we already know that a 3 cross 3 matrix.
Hello.
Hello, yeah.
Yeah. Sorry, I got disconnected.
Oh
Mhm.
yeah, sure, no problem.
So,
Yeah, like I was talking about like this function. We have to make the matrix to be identity function. So
yes.
we already know that like a 3 cross 3 matrix identity 3 cross 3 identity matrix looks like this. So
Yep.
like similarly 2 cross 2 looks like this. Like we have to make the diagonal elements 1 and rest other elements 0. So for making the diagonal elements 1, like what should be the condition? Like according to you, if I iterate on the for loop in the matrix, like I is equals to if say 0, I less than n, I plus plus, and for int j is equals to the like what according to you like the ones like by default we will in else part will keep 0 but according to you like these ones what special property they hold so that I can write in the if condition this thing to write that if that thing happens my element should be 1 like according to you what should it be like in terms of ing like see if like
Oh,
I am talking about like 0 0 it's there 1
yeah.
1 is there and 2 2 is there like do you understand like what, do you find the pattern like what happens in the diagonal elements
Oh yeah. Yeah. Like it goes up. I guess 1 1
means
2 2 3 3. Like
yeah
it, both
like
of them,
means
X and Y,
like
both go up by one.
both are same right
Yeah.
like if I equals to j that means it's a diagonal element we need to write this as like whatever our matrix let's say a only so a of ij is equals to 1 if it does not happen, like I is not equals to the rest of these elements, we'll make it 0.
Okay.
So this is how like we will make our aij is equals to 0. So this is our make identity one. Make identity. Identity yeah, like means our random matrix will be given to us like 2, 3, 4, 5. We just need to convert it to 1, 1, 0, 0. Something like that. So we will follow this code I equals to j, this one and this one. And then if it happens, it will be 1, else it will be 0. So I think, yeah, this is fine. You've done this. Okay. Yeah. Hmm. So basically now the next method is the copy matrix. So basically what we have given is we are given with a one more input matrix. A C matrix parameter is given to us. Copy it to current matrix this object use other to ensure the dimensions are compatible yeah like firstly obviously like we need to check if we talk about this one let me just copy it just a second yeah like copy matrix is about the copy matrix yeah like first of all like the first thing we need to check the dimensions
Yep.
check the dimension like it should be same of that our previous matrix whatever we have defined and then if it is correct we will go ahead and then just run a for loop. I think I don't think so there is a problem. Like just run a for loop less than n and I plus plus and like similarly for int j is equals to 0 and j less than m. I will write the code as well. I just explaining in this board and then we'll write the code as well. Then what will happen? Like already we have given this matrix. And suppose my class matrix parameter is A only. Like I am using the matrix A. Okay. So what will write?
Yep.
Aij is equals to like whatever I matrix was given. Like M was given, capital M. Fair enough. Just copying
Yep.
whatever is there. So this is just, I think it will be a simple one. So copy matrix is done. Now what is saying? Add matrix is okay. Fair enough. So basically they are saying we are given another matrix to take external matrix and return the result that is a sum between the current object and supply object. Use assert to ensure that the dimension of the two matrices are compatible. Okay. So basically, we have to add two matrices, right? Like suppose if I just give you an example, 1, 2, 3, 4, and we have to something like this. Firstly, obviously, again, and every time you have to check the dimension because both the dimension should be same for addition of two matrices. 4, 5, 6, 7. The final matrix, like we have to resultant matrix we have to return 5, 7, 9 and 11, I guess. Okay, this we have to
Yep.
return. So again, same this one, this code would be copied. Like, okay, let me just, okay, like this one will be again will be same. Wait, I'll just not make it defined. Means like again the for loop I am not writing again. Like in the inside the for loop I am writing directly inside the for loop. Like two for loop obviously will have to run again. And then what is the what you have to write? Like suppose I have initialized a new matrix as let's say n, capital N. So what I will write? N of ij is equals to our previous matrix, like whatever is our class matrix, plus m of ij. Just adding of both the term by term, right? Like here what we have done here. Oh, where it's go on. Oh, just a second. Here, like one will be added with four. So basically five is happening. So what is happening? Like term by term, like 0, 0 of this one will be added with 0, 0 of this one. This is how what we are writing here. Like Nij, this is our new
Yep.
matrix. This is our new matrix. So yeah, we are adding term by term. So yeah, I think this is done. Now let's move forward. Now this is what is written? Add x to each element of the current matrix. Return the resultant. Like what we have done? Nothing. This one. Wait. Mm, think I should copy here only. Yeah. This one like add I right. So this one just to copy. Mm, 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 mm. Okay. Basically what it says is so it yeah. So basically what it says is add elements. So what you have to do? Nothing. Like our matrix was Aij. So Aij, whatever our matrix, previous matrix, plus equals to x. Whatever I is added, whatever I and x, they could return I. So yeah, whatever is the input we are given, but you should not use the variable name I. You should name x. Like I is already used in that looping part, right? So use
Okay.
x. It would be better. Like
Yeah.
make it x here. Yeah. So yeah, this is simply like running the for loop. I'm writing the code inside this. All are writing inside the for loop. To for loop, obviously every time you have to run, and then just write this code to paste here. So this is also done. Then subtract two matrices. Similarly, I think yeah, it is same, right? Add
Yep.
matrices and subtract matrices. Just Aij, the condition is for subtracting. Just write quickly. Subtraction. If I just write subtraction. So like whatever our new matrices is like capital Nij, Nij is equals to, see from where you need to subtract, that is very important. It is written take C matrices parameter, return the difference between the it's not written from where to where, right? You understood, right? Like we can subtract from M to our original matrix, or this can happen like both ways. Aij minus like Mij, or we can write the opposite one as well, like Mij minus Aij. It's not clearly specified, but I think it doesn't matter. So yeah, like follow this one. Like if it's not given, follow this one. It would be better, right? So yeah, this is like subtraction is done. Then subtract again. This is the same concept. Subtract matrices. Here, what we have to do? Just write Aij minus equals to x. Like each element should be subtracted by x. Fine. This is important. Multiply. Like I think we have discussed unintentionally we discussed this thing, right, in the class.
Yeah.
Like
Mhm.
multiply two matrices. We haven't complete that. Yeah, let's try to complete it now only. This is very important. Like actually, I already know that like a multiply matrix will be encountered anytime soon. So yeah, multiply two matrices. Like we have made, I think the basic theory like what is happening, which is we need to run three loops. Let's directly jump onto the code so to understand better. Just go my VS Code. So like three matrices, three loops. I already told you like how it works. Just a second. Mhm. Yeah, basically like we want to multiply two matrices.
Yep.
Like firstly, let's try to define two matrices quickly. Say vector also need to include. Just include vector. Yeah. So basically, let's say I'm defining a matrix A. A like this is how you define a vector matrix. Like firstly the rows and then a 2D matrix, and this is the columns and whatever. Like let's say initially I put the values as 0. My first matrix. Okay, n and m are not defined. Let's say 3 comma 3, n equals to 3, and m is equals to 3. So it's like, similarly, let me just define matrix B. Or we can directly write the function as well. Like it would be better. Like, let's try to write the function void multiple, or not like returning the 2D matrix. We will return the 2D matrix. So yeah, like this is vector and multiply. What we will taking? We will be taking two matrices as input. So here A and here B. Okay, fine. Now basically also need to know the size. So n is equals to a dot size. I already told you to get the number of rows, just do the a dot size. And if you want to get the number of columns, just do a of 0 dot size. This is how we got the rows and columns. Now, very important, we need to multiply to matrix. So obviously, two for loops are obviously needed. But I already told you that one more for loop is required because there is a summation going on. Like, oh, just a second. Like, if I just talk about 1, 2, 3, 4, 5, 6, 7, 8, 9, and if I just write multiply with 1 0 0 0 1 0 0 0 1. So like what you will do, this will be multiplied by this 1 into 1. This will be like if I just write this will be multiplied by this plus 2 into 0 and this will be multiplied by this one with 3 into like again one more for loop is required for writing each element so that we can write it. So I already there is a formula like we can use that formula to write that multiplication. Like firstly, let's try to write iterate for each element. This is basic. This is we will every time we'll do in matrices. In j is equals to 0, j less than m, j less than m, j plus plus. Now very important. Like let's suppose I created one more matrices to restore the result of the multiplication. Let me copy this. Let me just copy the complete thing. So basically, let's keep the as answer. And now what's very important is we have run a for loop is equals to 0, k less than m, k plus plus. And what you will do is answer of ij, like we will do the summation, right? So plus is
Yeah.
equals to, firstly, from a of I k, we will multiply like this k into b of k j. This is the formula, like you can sort of remember, like from pattern we figure out this formula, like a of ik, like this comes a of ik, like k is running, k could be 0, 1, 2, 3, and like this. So k is running from 0 to n, so 0 to m basically, to be more precise. All we are running an a of ij, k, and this is would be fine. So yeah, like a of ik into b of kj. This will be, I think, would be fine. And yeah, for multiplying two matrices, suppose they are of m cross n dimensions. So obviously, the B matrices, I'm assuming they are n cross n matrices till now. But if they are of different also, so we know that like for multiplying, if I just talk about multiplying, like m cross n is a matrix is there. So this should be same. Like if this is A, so this should be n and something which z. This and this should be same for multiplication, right?
Yeah.
For multiplication of two matrices. So yeah, I'm assuming here they are same n and m. So yeah, that won't matter whatever you write here. But yeah, like for the limit for k is would be this one, like the number of rows on the A matrices. You have to write like m. So this is how a I into k into b k into j. Yeah, this is how just this is done. Like whatever now, if I just print my answer ij, if I just print my answer ij, this is my final multiple matters. We will see in the final code as well. I have written that final code as well for your assignment as well. I'm just explaining in terms of vectors. Okay, fair enough.
No, okay, okay.
Okay, like this is like this. Just remember this one. This formula is very important. Like what we have done here. Let's run another for loop from k is equals to 0 to m, and then I to k. We have multiplied and k to j is multiplied because this variable is very important because this row is we mean multiplying with this row. So this hits here what is changing? Column. So
Yeah.
basically this is why our column is changing. But here what is changing? Row. Here row is changing. So that's why k is written here. Because k is the variable part, right? I and j are fixed for this for loop. And this that is why here pkj works like that. So aik into pkj. Like this is a symmetrical pattern as well. So yeah, you can sort of remember it. So yeah. So let's move forward then. And if we multiply two matrices, and I think this is very simple. Each element multiply, so this is very easy. Just you do that aij multiply like star into star equals to x. Now, now again a question. Bool is diagonal. To return true, all the elements not on the diagonals are zero. Otherwise, return false. Like what is saying? It return actually. It's return true if all the elements not on the diagonal are zeros. Like what it is saying is what is a diagonal matrix?
It would
Diagonal.
just be the one that you showed. No?
What happened?
Wouldn't it be the one that you showed?
Yeah, no, no, that was the identity matrix. Like,
Oh, okay,
see,
okay.
diagonal matrix, yeah, that is also a diagonal matrix. But suppose this is also a diagonal matrix.
Okay, okay.
Like it should not be one only. It could be two, three. Like the diagonal elements are non-zero. That is diagonal elements are non-zero. Yeah. Like it could be anything. One, two, three. They can't be. They can be equal. They cannot be equal. Are non-zero. So the diagonal elements we define with I equals to j are not zero. All other elements are zero. Okay. So yeah.
Okay.
And now what we have to check, they're saying, is it a diagonal matrix or not? So what we will write, like if I is not equal to j, because I'm not bothering about the diagonal elements. I'm bothering about the non-diagonal elements. If if I is not equal to j, that means it's a non-diagonal element, right?
Yep.
Non-diagonal element. Now I want to check if it comes out to be zero. If it does not come out to be, suppose means like something like that, 2, 2, 2, 3 it comes out, like a non-zero terms comes out. It is not a diagonal element, yet it is non-zero. That means if, and then we will enter it. And now again we will check if our whatever aij is not equals to 0, that means it's not a diagonal element. We just return false. That can't this matrix can't be a diagonal matrix because non-diagonal element is still non-zero. So that it won't work like that. And suppose I run the complete for loop like this for loop for I to n and j to n. I'm this I won't enter. Let's suppose I don't enter in this if loop for entire matrix, then
Yep.
I will return a true here outside the both the for loops.
Okay, okay.
Means like this is yes, this is a diagonal matrix. This is a diagonal matrix. I'm not directly jumping on the code because like I want you to learn more, because like if we go through basic concept, like this is how you think, because if I show you directly the code, maybe you just mug it up and you can't solve a new question, right? So this is how we
Yep.
develop concepts, and yeah, it more interest also, if to be more precise.
Yeah, yeah. I get you.
So yeah, it's like if you find anything like like you feel free to tell me, oh, I'm not getting this. So yeah, like I will try
Yeah,
my best to
I'll
answer.
tell you more.
So yeah, this is we have done. Okay, the next part is identity. Again, this is slightly the change. Like if now we have to check the our matrix is identity matrix or not. Almost similar code, just a slight change. Like identity matrix, we know that what is identity matrix. We still discuss like it is a diagonal matrix. All diagonal elements as one. So identity matrix. And now what we need to check? We have to check now two things. Like you can get it right. Firstly, like we can use our this function. It would be better, right? Firstly, we
Yep.
will check using this diagonal matrix. Like firstly, if I tell it smartly, firstly I will check if it is not a diagonal matrix.
Mm-hmm.
I straight away return false,
No, okay.
right? Is diagonal, like whatever a, I return false. If it does not come out to be diagonal, so I just return false. Now suppose it comes out to be diagonal. Now also we need to check. Like we again need to go for the for loop. Int I is equals to 0 to I less than n I plus plus, and then similarly for int j is equals to 0, j is less than m, j plus plus. Now important thing is I need to check all of my aij's if like when our it won't be a it won't be an identity matrix if my aij sorry, it's also we need to check like I should be equal to j. That is a diagonal element, right? So like if I
Yep.
equals to j, and then a of I j is not equals to 1, that means it's not an identity matrix. Means we
No,
got
okay.
a diagonal element, but we don't find, like, suppose like this 2 1 1. It is not a,
Okay.
it's not a identity matrix. Basically straight away return false. And again the same scenario. Like if we come out for of these for loops, outside the for loop, like very outside both these for loops, will return a true. Like if we don't get a false on all iterations, we return a true. Yes, it is an identity matrix. Like if we don't fail, we pass. Simple logic.
Yeah.
So yeah, I think this is also done. Now the next part is bigger. Okay, how they define bigger? For two matrices A and B, we say A is greater than B if every element of A is bigger than corresponding element of B. Return true if the current matrix is greater than input matrix, otherwise return false. Like see, they are saying if every, it's very important. It's not written for any, it's written every, means and. This is how you judge
Yes.
the difference between and all, right? So
Yeah,
if
okay.
every element of A is bigger than the corresponding element of B. So going opposite, see, whenever you're writing a boolean function type, right? So try to find the false conditions. It would be easier. Like if we find a false condition, we just return false from here only, right? So our life become easier. So what I will do, instead of finding a larger element, I will find if I got a element in E, like this M, which is greater than our A, we straight away return false,
Yep.
right? So this would be better.
Yes.
What? So what we will write directly? Bool is bigger. Just directly write, like again, for loop 1, loop 2, and then what we will write, if I got mij, mij, maybe let me just check, can it be equalities be there or not? Okay, see, that's saying strictly A should be greater than B is bigger. They're not saying bigger or equal. So if I find this one, like here I can put equality, because suppose if my matrix is equal also to Aij, I just return false. Like it is not a, it can't be a big matrix. So yeah, just return a false from here only. And again, yeah, like loop ends, all loop ends, same stuff. Okay, repeating. So yeah, this is like return false again. Return true, sorry. This is like, yeah, like all elements satisfy the property, means it is, yeah, our matrix is greater, so it is bigger. Fine. Same stuff in the smaller one, I guess.
Yep.
For two matrices A and B, what we have to, like just opposite condition. This is for bigger, so just write for the smaller code. Small is smaller, nothing changed, just like the condition just reverses. Like if Mij is less than equals to Aij.
Okay.
Yeah. Now let me just check we have, can we put equal to or not? Like is smaller for every element of it should be like again equality will be there, because see if it becomes equal that means it is not smaller, right? So yeah, we have to
Yeah.
put equality as well. So just return false, and yeah, again if it all satisfies, then return like all loop ends. Yeah. So this is how we have done this part as well. Now this one is like bool equal. So basically two matrices are there and we have to check whether A is equal to B or not. Like for obviously equal matrices means if this is the failure which they didn't need to give also. Like every element of A is equal to corresponding element of B. Return true if the current matrix is equal to input matrix. Otherwise return false. Like, so yeah, can you help me with this one, like this equal matters? I think we have solved enough questions. You can try, give a try. Like again, yeah, loop one is there, loop two is there. Like what condition I will write in terms of INJ?
Like the for loop.
For loop, yeah, this is fine. Yeah, like we have written this for loop. Then if what should I write in the if loop? If part, yeah.
Then it
Like
will be
my
if
input
is
matrix, yeah, A. My input matrix is A, and our like given is M, or something like that. Yeah. Like again, the same thing. Try to think in terms of getting a false condition. Yeah.
oh false condition. Then in that case, it would just be greater than or equal to.
No, no, no. This is a this time this is equal. They are saying like both matrices are
Okay.
equal or not. So yeah. So what do you think? Like what would be the false condition?
The false condition if it's not equal to.
Yeah, yeah, yeah. So what should I rate?
So in this case, it would be if I
Mm-hmm.
does not equal to j.
A of I, right?
Oh, sorry, a of I. Yeah.
A of ij
Yes,
is
is not
not
equal
equals
to.
to M of ij, right?
Yeah, m of ij.
So yeah, these are not equal. That means they are not equal
Then we would
matrices.
work.
Just written what?
Then it would return the. Wait, sir. Can you go back to the question? Or like
Yeah,
the. Then it would just return the two matrix. Return true if the matrix is greater than or equal to the input of m.
no, 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 no. Equal means like both should be same. Like
Yeah.
one, two, 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 and other matrix is also two, two, two. That means they are equal. Like there's not greater or equal. Like if they are not equal, you will return false, right? Like they are not equal.
Yeah.
How could it be true, right? So, yeah, this is like true. And if all loop ends,
Okay.
like you got it right. Like means
Yes.
the
Yes.
corresponding element
Yes.
we did
Yeah.
find same. So that's why we return false.
False.
And
Okay.
all and this is return a true. So yeah, this is how it works. And yeah, I think this is done. Let's jump on to the code. So yeah, let's try to jump on the code. Happens. So yeah, I think we have enough time. So let's see the code. Yeah. So yeah, this one part one is there, right? Right. Hmm. 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 Yeah. So basically, this is I think we already discussed like allocating the matrix size. Uh, Destructor is fine. Allocate matrix memory matrix. Deallocate. We already know that. Get dimension
Yeah.
also we know that. Get element also we done. Replace, swap, resize also we have done. Read also we have
Yes.
done. Print also we have done. Make identity we have start. Okay. So yeah, the make identity we have to start. So yeah, uh, just a second. Hmm, yeah. So it says it's visible to you, right?
Yep.
Yeah. So this is basically we have to do it. And like if I just add here, I can okay, let me just add side by side. We can just add this thing, Control C. Mhm. So yeah, we can just make it plus. Yeah, so basically this is our make identity function. Like what we have done here. This is like you can do this way as well. Like what we have to do, making the identity function. Like what we have done. Like if I is equals to j, equal to j, then we will make the matrix. This is a turn. Do you know this ternary operator by the way, by any chance?
Matrix I equal equal.
Like, means this ternary operator how it works.
I
See the
know.
ternary okay, I
I
will tell you. See what happens is like this is something known as a ternary operator. Like if you this you can write in a if condition also. Like this is
okay.
a cool way of writing in one line. So like what it happens is like this is the condition, same as the if
Yes.
part. This is the true part. After the
Okay.
question mark, you write the if it becomes true, what you will do, and
Okay.
if it becomes false, what you will do.
What
So
would
this is
do?
a false
Okay.
part.
So basically, it's just taking true and false of the.
Yeah, 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 like yeah,
Okay.
true means true after true, what you will do, something like that. Like if I
Okay. So
equals to
after,
j.
yeah. Okay.
Okay, so this is the condition. Yeah, something like that. So if I equals to j, this is the same as like writing this matrix of ij equals to 1, and if it is else, a matrix of ij equals to 0. This is the same stuff. Like we can write it again as well. For the sake of simplicity, like we can write. Like maybe it's not familiar to you. Like if I equals to j, like we will write matrix of I j is equals to 1. Else we will write it 0.
Okay, okay.
Matrix of I j, like making an identity matrix. Yeah. Now this is a copy matrix function. Uh, I think yeah, like obviously, firstly you will check the dimension should be match, like and the obviously the starting and the ending part you need to check that they're same or not. Like adding copying two matrices both should be same. Okay, both dimensions should be same, and I think okay we are assuming here like both are same n equals to m. So here we are checking only one part. Okay, like if you take different dimensions it would be you have to check both the dimensions. Okay,
Yep.
so yeah, like copy matrix is fairly simple. Matrix ij is equals to m dot matrix ij, I guess. Like just copying, like this is our new matrix, like like this is our original matrix and we have to copy from from m matrix. So m dot matrix ij, we just copy the stuff. Fine. So
Okay,
we will
okay.
just copy and add two matrices. Again, we need to check the dimensions. We check the dimension for storing resulting matrix. We like created another matrix to store the results, which is known as result. Then again, two for loops. And then what I written the same code here, like result dot matrix ij is equals to like this is our original one, our class matrix, and this is our like we have given with m parameter. So m dot matrix ij, so m is a class object of that. So dot using we are using that matrix of using of object, like we for matrix we are getting this using like for getting the matrix of the object we just use a dot method of this is our object and matrix. So yeah, like here we define our member as of matrix, right? So
Yep.
to get our matrix so of an object. So yeah, this is
Okay. Got
so
it.
what we here we have used using dot method we use the matrix, and this is our class matrix, and just we store in our resultant dot matrix ij. Like means I'm saying we can give here matrix also, but they are giving
Yes.
object directly object of our class. So for getting the matrix out of our object we have to use the dot method for getting the matrix ij. Okay.
Okay, okay.
So this is result. Subtract matrix are like fairly simple. Same stuff. Result 10 and then result of matrix ij is equals to matrix of ij minus m dot matrix ij. Okay.
Yep.
Yeah, this is important. Multiply matrix. So firstly, check the dimensions are same or not. Result n. We create a new matrix. Now, very important. See what you have to do. Yeah, this stuff like result dot matrix ij, the final plus equals to, because you have to sum over all the values of k, matrix of ik into matrix of ikj. Like this is our b matrix, sort of like we just write it. Like, this is our b matrix. This is our a matrix. It's like similarly as a of ij into b of kj. Okay, same stuff.
Yep.
This is really what we are writing here. So yeah, this is how it works. Now this just a second. Yeah. Now checking the diagonal one. I already told you whenever you come encounter this type of like is diagonal like bool type of functions, try to find the false condition. It would be better. So what we have
Okay,
done,
okay.
like for I is not equals to j means it is not a diagonal element, and if it is not a diagonal element and it is not zero, that means it is not a diagonal matrix, because a non-diagonal element is non-zero. That means it can't be a diagonal matrix. We just straight away
Yep.
return false from here. And if it not enter in this if loop, like we did not return until all the members are all exhausted of the matrix, we return true. From here, we just return true. Okay.
Yeah, okay, okay.
Okay, yeah, like again, the identity similar. Like we can do a cool stuff here, like what I would told you here. Firstly, we can check if our like is diagonal. If not of like
Mm.
our
If
comes
not,
out,
then we'll.
if it not comes out to be diagonal, like our what is our matrix? Our matrix was a matrix IJ. So yeah, like we have to okay, like it directly we can call like we already don't need to pass anything and then return false because it will reduce our computations, right? Why we need to
Yep.
check every time if it is not diagonal? Why? What's the matter of checking? So yeah, like and now here we come means it is a diagonal matrix. And now but just we need to check like if our if the diagonal elements is not equals to one. Like again the same stuff. The we are checking the opposite thing. Like if it is not one, that means it is not an identity matrix. We return a false. So we it's not needed now this thing because we already check for non-diagonal elements. It is a diagonal matrix. So yeah, something like that. Fair enough. So I think, yeah, let's check. Am I audible?
Yep.
Okay, cool. So basically, like, suppose I just like this is not exactly the structure you want. Like I just wrote the class in same function and test function in same. I think you're able to write in the separate files, right?
Yeah, yeah, I can do that.
Okay, okay, fine. Like suppose two matrices I want to write. 1, 2, 3, 4, 5, 6, 7, 8, 9. Like again, second matrix I am writing 2, 3, 4, 1, 2, 3, 4, 5, and 6 here. So basically, this is how like some methods I wrote. This is our matrix 1, this is our matrix 2, and then this is sum of matrices. Like this 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 4 is 7. This is sum of matrices, difference, and product of matrices. So yeah, like we can write more functions. I just wrote some simple functions. Uh,
Yep.
this is like yeah, making two matrices of that object of sizes 3, 3, and then add, subtract, multiply. You can check diagonal or not. So that's it. Cool.
Okay, okay. Yep.
Now, I think yeah, we can move. Like I don't think we'll be able to complete the completely the second question, but yeah, like we can discuss some parts of it. So in I think in next class we will able to complete the complete part. Okay.
Yep.
So okay, where is that second part of? Okay, yeah, this is I think yeah. Wait. Now the difference, like this is also we studied actually in our
Mm-hmm.
class. Like what is the difference between the first part and the second part, second question? So the
Yep.
main difference is like this is very cool. Like in professionally, they pro what they want to specify is operator overloading. We have discussed, right? Like plus
Yes.
operator, how it different concatenates in strings, adds in integers, how it works in decimal, something like that. So and we have seen the example of vectors addition also, right? So
Yeah.
same stuff they are using in terms of matrices. You have to do that all functions and just using these operators to define that. So yeah, like it shows teammate continue okay, all requirement identity data members are same as before. Modify the member functions and into overloaded operators while keeping the other functions as same as before. Like some functions we don't need to change, something we need to change. Suppose like the read matrix okay, we will start. Like, yeah, something like that. What you need to do, like print how it is done. Like, firstly, let's try to see the copy matrix thing. Like, we want to copy, like, we know the function, but just we need to check two matrices are equal or not. You don't, we don't need to use now. Means copy matrix. We need to copy the element. Now we don't need to write the function for that. Now we will use sort of operator overloading. Like if I just show you the example, like one example, if I just show you, like
Mm-hmm.
this is how we need to do. Okay, this is the same stuff. Yeah, this one. Like we want to do what you want to where yes, this is the input. Yeah, this is a copy part. So yeah. This is how I already told you. Firstly, we write the class thing. Okay.
Yep.
This is the referencing. Yeah, this is very important because we want to change this function as well. So this is like because we are adding references because we want to change our original matrix also, right? If we remove this, our original matrix won't be changed. So that's why you need to add this ampersand symbol as well. This is operator we discussed in the operator overloading part, our like in the polymorphism lecture. And now, what operator we want to overload? This one, equal to operator. We want to overload, and this is the if I just write, yeah, this is our input. This is our input, and this is our in operand. This is our complete operand. Now we need to copy the element. So basically, firstly, delocate is fine. Copy matrix we will call the method the copy matrix here means but in a for a user he don't need to call the copy matrix function something like that. Like what I'm trying to say is okay, just a second. Means firstly what was happening, like if I just go in the board, I just like firstly the user was calling the copy matrix function from main function from main. But now
Yep.
what we are doing? Now what we are doing is like user is doing this thing matrix M is equals to A plus B. You got it? Like
Yep.
he is writing in terms of plus. Now this in our code, okay, this plus is overloaded and there obviously the copy matrix function will be called, but not we will won't write it explicitly. This is overloaded and our like class will call the copy method. This is the difference. Just this is the difference. Like obviously the copy method will be called because we need to copy the elements, but not by the user. See, if I just show you here like sum of matrices. This is the class name and this is the object. Now what we are doing is we're directly adding mat1 plus mat2 means two matrices. Like if I go in the previous example, we are
Yep.
doing this thing. We are calling explicitly this function we are passing this mat to. This is not professional, right? This is that's why they wrote in terms of proness and professionalness. Okay, you do it because you don't know the function name, right? What
Yep.
I wrote add matrice, but suppose my add spelling is a capital, but I will be pissed off like a is capital or not, small or not, I don't know, right? But here I don't need to know. Here I don't need to know that. Here just need to use the regular plus. This everybody knows. Obviously
Yep.
plus. So this is the difference. We have to use the operating overloading wala part to try to understand it better. So I'm discussing two, three uh, methods and I want you to try on your own. If you find any difficulty, then we will discuss it tomorrow. Okay. So let's try
Sure.
to
Sure.
discuss
Yeah, because I
two.
think the second one I haven't done yet, so I'll try again tomorrow,
Yeah, you will try it
and
two
then I'll
days
let you know.
later.
Yeah.
Yes, yes. So yeah, like mostly this is this. Let's try to write one thing like a copy we have done. Okay, let's try to write for add. So like if I just write in terms of add, how
Mm-hmm.
it works. So this is how it works. See, basically, yeah, yes, it multiplies there. Yeah, like add is there. Yeah, yeah. So again, firstly, you need this is not this is adding two matrices. Like firstly, obviously the class name, then operator, and then which operator you want to overload plus, and this is our input matrix. Then what we have to do again checking and storing the result, and this is result the same stuff. This is the same code what we are doing it before, adding two matrices and just resulting and result on matrix ij. This is the same stuff you are doing return result. Just just this change is needed. Like for operator plus, we firstly we are defining the operator method name, function name, then add to matrix. Instead of that, we will just write the operator overloading wala part, and this is how it works. So yeah, like if you have any questions like what we have discussed today, this is I think we just started with all this, how we are doing, checking diagonal elements, multiplication. Yeah, like if you have any doubt, yeah, like feel free to ask.
Okay, sure.
Yeah. And like if you have any doubt, yeah, like this is like try to do that. Okay, how equality is there, same stuff, checking
Yeah.
things right
Give me
inside the
one.
code. Yeah,
Let me just look. Or just
yeah, yeah, check it.
anything I. Yeah. Yeah, no, I think this should be good.
Should
I
be
think tomorrow I'll try it,
yeah.
and then I'll let you
Try
know
to
whenever I just need help.
yeah. This is important. This is very
Yes,
interesting. This is
yes,
the fairly easy stuff. Like first part. First part is
yeah,
not easy, but fairly normal stuff. It is
yeah,
important. This is the crux of OOPS, right? You will using
yes,
the
yes.
operator overloading for a part. So yeah. So yeah, like try to it tomorrow. We'll discuss it tomorrow, and if you don't have any doubt, we will move forward to abstraction
Yep.
lecture. Okay. So
Okay.
yeah. So yeah, like so today good to have a good question.